Okay, we are finally starting a little bit of trigonometry. So in section 6.1, the first thing we're going to have to get out of the way is a bunch of vocabulary. So I'm going to go through this list, kind of go through some pictures of everything, and try to make things clear for the vocab part. Okay, here's something that's going to be kind of new for us. We're going to be drawing angles, but all of our angles, we're going to start on XY axis. Okay, so I'm just going to get 3 examples going here. Okay, the first vocab word, the initial side. What that means is the beginning side of the ray. So if I start in this first picture here, usually we start the initial side on what we call the positive x-axis, and I would call that the initial side. Okay, you can really start it wherever you want, but so we all have kind of a uniform way of putting angles on the axis. We're going to put the initial side on the positive x-axis. Now the terminal side, it can be wherever it wants. I'm going to do one kind of over here in the second quadrant, and that's something too we want to talk about. Make sure we know where all the quadrants are. 1, 2, 3, and 4. Okay, so if I push the terminal side, it just means the ending part of the angle of the ray. So initial side, terminal side. And then when I talk about the measure of the angle, what I want is the opening from the initial side to the terminal side. That would be the measure of angle. So let's kind of give this one a measurement. Let's say it's 100 degrees. Okay, now, new thing, positive angles. We have always thought there have to be positive angles, but now we're going to talk about the idea of a negative angle as well. So positive angles are measured in the counterclockwise direction. So if I looked at my second XY axis here, counterclockwise would be like this, going backwards around a clock. So if I give an angle of, let's say, positive 50, I would say, here's my initial side. My terminal side would be in the first quadrant. That would be a positive 50 degrees. Okay? Versus if I say a negative 50 degrees, negative are going to go clockwise. So this way around. So again, same initial side on the x-axis. Let's do a negative 100 degrees. Okay, so it would be something like that in that direction. Now, the opening of the angle, we're still going to label with a positive number. The negative part just tells me to go clockwise rather than counterclockwise. Alright, the next word, standard position. The vertex of an angle is at the origin, and its initial side is along the positive x-axis. So all the angles I've drawn here are in what we call standard position, with the initial side on the positive x-axis. Okay, the next word over here, coterminal. 2 angles that have the same initial side and the same terminal side, yet different measures. Okay, how is that possible? Let's take a look at my third XY axis here. So if I have initial side here, let's put terminal side here again, and let's call that 120 degrees. Okay. Now if I think about it, we're going to talk about going around the XY axis a bunch of times, once, twice, 3 times. So think about the idea that a full circle, so this little blue, is 360 degrees. So if I went all the way around the circle one whole time and then ended up on that same initial side there, I would have 360s all the way around plus another 120. So I get 480 degrees as a coterminal angle with 120 degrees. Okay? Alright, now, the next one down, the reference angle. Okay, now the reference angle is when you take the terminal side, connect it down to the x-axis, always the x-axis, and then the reference angle is the angle in here, this little sliver, I'm going to color it in a little bit, from the terminal side to the x-axis. So if you look at my 120 degree example here, the reference angle in there would be a 60 degree reference angle. Okay, so it's always from the terminal side to the x-axis. Alright, the next idea we're going to think about is a different measurement. So instead of talking about degrees, we're going to talk about something called radians. Okay, if a circle of radius 1, alright, so here's my radius 1, 1 unit long, with the vertex of an angle at its center, then the measure of this angle in radians is a length of the arc that it subtends. Okay, let's think of kind of an easy example first. Look at the second one over. Radius 1, If I asked you to tell me circumference, hopefully you'd know it's 2 pi r. So with radius 1, the circumference would be 2 pi. And remember what circumference means. It means the distance all the way around the circle. So this whole red measurement would be a 2 pi radian measure. Okay, we call it radians. Now, if I want to talk about 1 pi, it kind of makes sense then. If 2 pi is all the way around, 1 pi would be halfway around. So I could write a little conversion here and say that 1 pi radian is the same as 180 degrees around the circle. Okay, and think of, also keep in mind, pi is about 3.14. So if I go back to this first example and I ask you for where 1 radian would be, 1 radian would be something like, I don't know, here-ish, where the arc is about 1 radian. Okay, so what do you think about the next one over? Half a pi radian. So I'll kind of draw on top of this one, and we can do the other one in class tomorrow. So, radius 1, half a pi radian. If a whole pi is halfway around, it should make sense that a half a pi would be a quarter of the way around, or the conversion could be 90 degrees. Okay, so now look at this little chart here. I have 180 degrees is the same as 1 pi radian, or 1 pi radian, or 1 radian is the same as 180 over pi. So 1 degree is pi over 180 radians. Okay, so let's do a couple conversions. Let's figure out how these work here. So if I have 60 degrees, and I want to know how many radians that is, the work you want to show is 60 degrees times pi over 180. That should give me pi over 3 radians. And if we want to go the opposite way, pi over 6 radians, turn it into degrees, so the degrees on the top, that should be the same as 30 degrees. Okay, some of these conversions and positive, negative angles, we'll talk about these in class tomorrow. So I just want to make sure you think about, for the next few, we need these formulas. We need to know that circumference is 2 pi r, hopefully that's okay with you, and we know area, pi r squared. Okay, so 2 big things we need to know. Okay, so if I'm talking about the length of an arc, I believe your book uses an S. I'm not quite sure why. What we're going to be doing is we need to find the angle over 360. In other words, what fraction of the entire circle is it, times 2 pi r, or the angle over 2 pi times 2 pi r. And then if we do the same thing for area, the area can be theta over 360 times pi r squared, or if you're in radians, area is theta over 2 pi times pi r squared. And we'll talk about the abbreviated forms of those formulas. So make sure you have those written down. We'll talk about a lot about those. Okay, let's do a couple examples. Find the length of an arc. Whenever you see length, you should be thinking circumference of a circle with radius 10. Okay, that subtends is just a fancy word for it determines this arc. A central angle of 30 degrees. Okay, let's just kind of do a 30 about this big. Alright, now once again, whenever they're saying length of the arc, they want this length from here to here. Okay, so if I start my formula, and sorry about that messy S up there, arc length would be the angle over 360 degrees times 2 times pi times the radius. You can just leave pi in the answer. So S is going to be 1/12 times 20 pi. We'll reduce that a bit. So we're going to say 5/3 of a pi is the arc length. Okay? Alright, let's try one in radians here. Length of an arc, radius 5, subtends an angle of pi over 4 radians. Now, you'll kind of get used to seeing this, but pi over 4 is about 45 degrees. I'm going to leave it in radians though, so we can see what the other version of this formula looks like in radians. So if all the way around is 2 pi, I would say the arc length is pi over 4 over 2 pi times 2 times pi times the radius of 5. Now the good news about keeping it in radians is, take a look. These 2 pi's cross off every time. So really what I have is 5/4 of a pi as my final answer. Okay, let's do one more example. This time we're going to focus on the area of the sector. Remember, sector from geometry is just like the pi piece, with central angle 60 degrees and radius 3. Okay, so 60 degrees inside, radius 3. We're in degrees, so if I'm talking about area, it's going to be the angle over 360 times pi r squared this time. Okay, so that would be 1/6 times 9 pi, or 3 pi over 2.